Eric, this brings the wow to the wall of wind.
We are now inside the wall of wind facility. This is the contraction zone. We talked about we had to get the speed of a hurricane, and this is the area that narrows, that says if it enters at one speed, it'll exit faster on the other end. So that was accomplished with the contraction zone, but we had to create additional turbulence as well. So these three spires help us create some of that turbulent nature of the wind as it hits the spires.
It makes it twist and turn.
Absolutely. And the spires also hold the water spigots. This is where we bring water into the system to replicate that 8 inches of rain per hour.
Now, this obstacle course
Right.
plates, it kind of reminds me of a jet wing. What is the purpose of these? What do they do?
Well, as you know, meteorologically, wind increases with height, and it's called the atmospheric boundary layer. Here at the wall of wind, these plates help do that. They can slow that wind down so that in this flow management, wind will increase with height. And now we're as close to Mother Nature creates in the real world.
So all the wind rushes through here and then it reaches its point of research, right?
Right. And that's why we're here, to do research. So that wind, carefully created and calibrated, makes it to this point. So this is the turntable. This is where all our testing structures then would be placed.
Now these are transmission line towers. What's being done in this specific research application?
So the whole purpose of this project was now to measure what is the wind loading that's going on across these towers from top to bottom. All that's being measured, and all our projects get measured. That data coming in gets fed down under the turntable where we have a mainframe computer. It's then collected and then sent over to our control room where it's archived.
And behind us, I see this incredible netting structure. It kind of looks like a Top Golf type of a place.
It does.
And a big wall.
And you can imagine, when we go to those high speeds, if something's going to go blowing out the door, we have to catch it with the netting and then our debris wall in the back.
And that's over, 100 yards down the way. So this stuff can really fly.
It can fly a long distance, which really shows us quite dramatically in a major hurricane, that flying debris, how far it flies and how fast it flies.